Okay, so today we're talking about permutations and combinations again, but particularly focusing in on combinations, and there's some really hard problems you're going to learn how to solve today. So I'm just reviewing a little bit here, and permutations you can either do with blanks, or you can do it with like a 3p3. Let's do one like that to make sure you understand that. Let's say I had 8 people in a race, and I was going to have 3 places, first, second, and third. That's how I would figure out the total number of ways they could finish. Would you please right now use your calculator to do that, and then tell me what it would have been if you'd have used blanks. If you wish to borrow one of my calcs, no problem. Just leave me a cell or a shoe. Okay. 8p3. In case you forgot where it is, pull up my calc here and go clear that out. 8p, and that's under math, PRB. And there it is, the p. Oops, right there. 3. And there are 336 ways. Raise your hand if you had that one right. Okay, good. Yes. Yep, that's what I'm just about to ask you. So, think of it as choices when you have blanks. How many choices are there for first place? 8 choices. Times how many choices are there for second place? Now there's 7 because I already used one up. And then 6. And if you do 8 times 7 times 6, you get the same exact answer. Okay. So blanks work pretty well also for this kind of a problem. Oh. Okay, so here we go. Back from our little break there. How do you know if it's a permutation or combination? Basically, if it's committees or things that are not ranked, then it's a C, a combination. Permutations are like a race, a rank, anything that's like first, second, third, that kind of thing, president, vice president, etc. Those things are permutations. The order matters because president is way different than vice president. All right. Here is the kind where they get challenging. So get to that screen with me, and you want to set up a few of these with me for practice so that you get this for tonight. So Chipotle. A lot of people like Chipotle. I've got 11 toppings listed here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 toppings, and I'm going to choose 2 of them. I know that's not real. Most of you guys are going to pick multiple things, more than 2 to throw on your burrito. But if you could only pick 2, it would be 11C2. Do you get that? Yes. There's 11 things, choosing 2 of them. All right, and that would come out to 55 different burritos if you can only pick 2 toppings. Do you think that if we make it picking 3 toppings that we could make more burritos, more kinds of burritos? Yes. Yes. In fact, specifically, you can make 165 if you make it 3 different toppings. So you see that went up a lot. It didn't just double, it actually tripled when I added 1 extra topping. So a lot of you guys put on like 6 different things as you go through. You know, like you like the rice, maybe you like the beans, some of you don't. A lot of you like cheese, gonna throw on some meat. I don't know, what else do you guys like? Sour cream. Sour cream, yep. The guac is good. It's still expensive. It's like $1 or something, $1.80 or something to put on, but I love the guac, I agree. Corn, some salsa. Yes, you can. You can actually get multiple meats. So like half pork and half beef. Yep. Steak and chicken. Yep. All right. So this one just requires a little more reading. Don't just slap in 9, choose 3, because that's not it. Read it quick. Try to figure out what choose what it is. What see what. Pause for a second while you figure that out. Once you're done, zoom in on it and turn it my way and keep it there. Then I'll know you're done and locked in. Just what, see what. Read it close. All right, so hopefully you read this closely and realized there's 9 people attendance this year, including this year's committee. That meant when we pick for next year's committee, those 3 people can't be picked. Therefore, it's not 9 choose 3, it's what? 6 choose 3. There's 6 people left that can be picked. Because, like, let's say these 3, that looks really bad, but those 3 already picked the committee, or did the committee this year, we can't pick from them. We got to pick from these guys. So it's 6, choose, 3, whatever. Okay, too scary. And by the way, that answer would be 20 ways. And I hope you'd be able to do that this way too. 6 factorial over 6 minus 3 is 3 factorial, and an extra one of those, 3 factorial. And that would be 6, 5, 4, 3, 2, 1 over 3, 2, 1, 3, 2, 1. And these are all multiplies. And then I could go 3, 2, 1 cancels 3, 2, 1. And 3 times 2 makes 6, and that cancels the 6. And I'm left with 5 times 4 is 20. See? I wouldn't have even needed a calculator to get to 20. All right. Now, here's where it gets real. This one is going to be a tougher question. I know those look yummy. Okay. Ever had Mrs. Richardson's? No, wait. That's the hot fudge. That's really good. Who's been to that one at the state fair? There it is. Sweet Martha's. That reminds me of the Sweet Martha's cookies all piled up in the bowl or the basket, bucket. All right. This one is intense. Pay attention. You don't have spaces on yours? All right, then just cross off this then to not be confused by it. And then the question still, even without spaces, you should be able to read it. I know it's lame, but okay. You can always look up at the board too, you know. Back in the old days, didn't have iPads where you had it on your own file. You had to look at mine. All right, so here we go. A bag of cookies has 6 chocolate chip, 5 peanut butter, and 1 oatmeal. If he selects 2 cookies at random, find the probability they selected 2 chocolate chip cookies. All right. Do you agree that probability always is what you want over what's possible? Do you remember that? Okay. Let's start with what's possible. I encourage you that on probability, it's always best to start with the denominator. Would you agree that there are a total of 6 and 5 makes 11 plus 1 more is 12 cookies out there? And you're going to choose out 2 of them. Do you get how I just did that? Okay. That's how the bottom goes, is those are the ones that are possible. There's 12 possible, and I'm picking 2. Now, on the top, you have to be more specific. What did he want? He wanted 2 chocolate chip cookies. That's what he wants. So then you got to break up the top into the little parts. The bottom is all together in one big group, but the top is made up of 3 things. Chocolate chip cookies, peanut butter cookies, and oatmeal cookies. And think about it this way. There were 6 total chocolate chip cookies, 5 total peanut butter, and 1 oatmeal. All of that just makes sense, right? I just am writing down the info from the problem. Always multiply your choices, so there's a little multiply sign in there. Then the only other thing I need is a number right here, and here, and here. And that's about how many do I want? How many do I pick? There are 6 chocolate chip, and I choose 2 of them. Then how many peanut butters am I going to pick? 0. And how many oatmeals am I going to pick? 0. And you can save yourself some time because anything choose 0 just comes out to 1. So those 2 parts are just 1 and 1. And obviously when you multiply by 1, it doesn't do anything. So you pretty much just need to do this part, figure out an answer, this part, figure out an answer, divide it, you'll get a decimal. Try it. See if you know how to enter those correctly at least. Go ahead and type them in right now. 6C2 over 12C2. I get if you don't get how to set up the problem, that's annoying, and I'm going to help you by doing another couple with you, but at least you got to make sure you can put these in the calc correctly. If you got 0.23, you're doing it right. All right, good. Okay, now I'm going to do that other part here. The 1 chocolate chip and 1 peanut butter cookie. All right. That's the same exact situation that there was 12 and I'm choosing 2, and I have divided up into the 3 kinds. Chocolate chip, peanut butter, and oatmeal. And there were 6 chocolate chip, 5 peanut butter, and 1 oatmeal. Now all I got to do is write in how many I wanted. There were 6 chocolate chip and I'm choosing 1. There were 5 peanut butter and I'm choosing 1. And then how many oatmeals can I choose then? 0, because I only get to have 2 cookies, so I'm choosing 0 of those. This I wouldn't even type in the calculator because it just equals 1, but this I would multiply on the top. I don't know how fast you are at doing these, but it should come out to 0.45 if you do it right. All right, let's try a different kind of problem. Same general idea, but except this is cards. All right, find the number of 5-card hands that can be dealt. Do you agree that if you pick up all your cards at once, like we were playing, say we're all playing cards. I deal you a bunch of cards. You got all these cards sitting in front of you. If you pick them all up at once, it doesn't matter what order they came to you. Because you just picked them all up at once, right? So the order doesn't matter. So this is a C question. Next, how many are there total? 52. That always goes here. See, I'm almost halfway done with the problem. In fact, I am. There's only one number left. 5. There. 52C5. If you actually type that into the calculator, you'd be surprised how many different kinds of hands you can get. There are 2.5 million hands you could be dealt. So if you feel like you've played a lot of cards and you've never been dealt a really good hand, well, it's probably because there aren't very many really good hands, and there's 2.5 million different hands you can be dealt with 5 cards. So it's not likely that you're going to get the ultimate hand, which would be like ace, king, queen, jack, 10. Okay, that is an awesome hand, but you'll probably never be dealt that unless you play 2.5 million hands of cards. Even then, you're not guaranteed. Okay, find the number of 5-card hands with 4 hearts and a diamond. Notice it's not a probability, so it's not a divide. So it's just a bunch of C's. And anytime they break it up into parts, like hearts and diamonds, you should break it up into parts. In fact, exactly 4 parts for cards. Clubs, spades, hearts, and diamonds are my kinds. Notice I won't be using those letters. It's just to help me keep it straight. These all get multiplied, of course. How many total clubs are there? 13. There's 13 spades, 13 hearts, and 13 diamonds. And then you got to ask yourself, how many do I want? I use this information. 4 hearts. Okay, wait, where are the hearts? There they are. 4 hearts right there. And 1 diamond. 1 diamond. Diamond's right there. 1 diamond. If I get 4 of that and 1 of the... I already have all my 5 cards. That means I need 0 of this and 0 of that. And what does this equal again? 1. And what does that equal again? 1. Okay, so no need to type those into a calculator. It'd be 13C4 times 13C1. Remember, you multiply choices. I've been telling you all these little things that are eventually going to come together for you. Like I always said, multiply your choices together. Here you go. It's another reason why I was saying that. Okay, 9,295 hands. That's a lot of different hands that have 4 hearts and a diamond. It's because there's a lot of different options for what kind of hearts you could have, or what kind of diamonds you could have with them. All right. This last one is good because kids go, well, okay, so I got to divide out the queens, and they get that. And they put, okay, I got queens for this, but then they're like, well, what about all the other stuff? If this is queens, and I have 4 queens in the deck, and I want to have 2 queens, kids forget about what to do with the other part. Well, think of it this way. You need all of them there, just like I did clubs, spades, hearts, diamonds. Do you really want to list out all the other cards that are there besides queens, like kings, jacks, 10s, 1s, 2s, 3s? No. So you just do one other thing. So there's queens and what do you think? Not queens. Anything else that's not a queen. Okay, so if there's 4 C2, why can't I just be done? How many cards are there supposed to be? There's supposed to be 5 cards in your hand, and you only have 2 of them so far. So I got my queens and my not queens. there's 4 queens, and there's 48 not queens. And so far, I've only got 2 cards taken care of. Do you get how this other one has to be 3 then? All right. These are the hardest. I think these are top 2 hardest kind of problems that you will see on your big probability test, which is coming on, well, the last of the 3 parts of probability is going to happen on Tuesday. It's going to be a quiz. Then we're going to have a review day next week of all the parts of probability. And then we have the cumulative test. The cumulative test doesn't like count way more than everything else. It actually counts like everything else. Just like a test, like a normal test you've had so far. So it's not like super important except for this. If you bombed any section and you want to do a retake, the cumulative test next Thursday is your retake. It's your chance to raise any old scores. So let's say on the very first test, a lot of you got like a C or something. Say you have a C on the first test and it's kind of hurting your grade. Then that cumulative test next Thursday is your chance to raise that score. If you do better on the test on Thursday than you did back 2 weeks ago, and you sign off on the little thing that says, I think I did better and I want this to count as a retake, and you're caught up with your homework. If you've been skipping homework, you got to go back and do it. Anything in the grade book that's missing, okay, has to be turned in. I'm not going to go try to find old assignments that aren't in the grade book, but anything that's in the grade book has to be in. And if you've done the corrections on that test that you did bad on, but I pretty much always make you do corrections if you do bad on tests, so you probably already got your corrections done. Then you can raise your grade. And that makes a big difference. I've seen kids go up like 2 grades after they take the cumulative test. They have a really bad grade on one test, and they do well in the cumulative. Then they can erase an old bad grade, replace it with a big, like an A or something, and then on their cumulative test, they also did well, obviously, and so then that helps your grade too. So these cumulative tests can help a lot. But it also can hurt you if you sign something saying, I think I did better and you did worse. We will go back and lower your grade if you did worse. So if you have like a B, you may not want to risk that chance of it actually going down. If you have like a C or a D and you feel really good about it, I'd sign the little thing because you probably got better than a C or a D. You'd know it if you had worse than that. Okay, so that's a little reminder of how the cumulative tests work. This next test is going to be on this stuff. It's on Tuesday, and it'll have lots of these C questions on it. Instead of doing more of this since the lockdown took some of our time, I'm going to just jump right into the homework with you. So everybody find the homework for today, and I'll help you with the first problem here. Okay, so here's the homework, and the first question, 2 meats and 2 cheeses. All right, I hope you've had a chance to read it already, but basically, there are different kinds of meats, different kinds of veggies, different kinds of cheese, etc. And how many ways can you make a pizza with the following ingredients? Notice it didn't say probability, so it's not a big fraction. I just need to figure out some C's. They divided it up into meats and cheeses, right? And how many meats are there out there? 6. How many do I want to choose? 2. And how many cheeses are out there? 2. And how many do I choose? 2. And then what do you do with choices? You multiply them. And you'll start noticing some patterns like this. When you put in 2C2 on the calculator, do you know what the answer is going to be? 1. Because if you have 2 things and you're going to choose both of them, how many ways can you do that? Just 1. You have to take them both. So you'll maybe get faster at putting this into the calculator, but this one would just really be 6C2 because the other one's just a 1. All right, there's not, at the beginning here, the very first problem's 1 and 2 with all 7 parts. None of them are probabilities, so don't make fractions on any of those. Those are going to come later. Okay, that's all I got for the video for today.